practice questions where we're trying to find the equation of quadratic functions. That's our 3.6 practice. Oops. All right, so first we have some textbook questions. Now, I know you have the answers to your textbook questions, but you don't have solutions. So I thought maybe we could walk through one or two of those questions together, kind of get our bearings on how these questions work in case we're not quite comfortable with them yet. So I'm going to choose maybe 1C from the textbook to look at first. So we'll look at 1C, and we'll look at 2G after that. And hopefully you can try the rest of those textbook questions yourself, and then we'll go through the solutions for these other questions. Okay. So we'll do question 1C from page 233. All right. So the question asks us to determine the equation for the parabola in question 1C. Anytime someone asks you to find the equation of a parabola, we first start by writing our general, we call vertex form of a parabola down. Okay. We do that first before we do anything else, before we think about anything. All right, and now we're going to start looking at this parabola and looking for hints about values in this parabola that will help us fill in values or some of these letters. We need to know that we need to fill in A, H, and K with numbers, and then we're done. We've written the equation of this parabola. And so the best place to start is to start by looking at the vertex. The vertex here is at 1 in x and -4 in y. So I'm going to write that down. Vertex equals 1, -4. Okay. So if the vertex is at 1, -4, remember that is our h and k value. Our vertex is our h and our k value in our general form. So the next thing we can do is we can rewrite this equation. Y equals A, and we have x, and instead of minus h, we have minus 1, which is k, or pardon me, which is 1. And we square it, and then we add, and here we have a -4, so k is our -4 value, so actually I would change that to a -4. And here we're well on our way. We've all we really need to do is find this A value, and then we're done. So there's a couple of ways to do that. One is to just look at the graph and see if you could figure out how much it's been stretched or compressed. And actually, that will definitely work. Normally, a graph goes over 1 and up 1, but this graph goes over 1 and up 1, 2, 3. So you may be able to determine for yourself the A value in this case. It's probably 3, right? However, maybe that isn't intuitive to you yet, and that's fine. We're going to go over a method that works every time. So the next piece of information we're going to need is a point, an x and a y value that this thing passes through. Some point is different than the vertex. And if I look, I can see the graph looks like it passes through the point 0, -1. So I'm going to use that point. So our parabola, so the parabola passes through the point 0, -1. So we're going to use that point, and we're going to say that's our x value and that's our y value. We should be able to plug those in for x and y, and then only have a one variable equation. Then we'll just use algebra to solve for it. So I'm going to plug y is -1. A doesn't change, and instead of x, I'm going to write 0, take away 1, squared, -4. And that's fine. We're going to solve for A. Before we do any algebra, we should do any simplification we can. So this, in the brackets here, we have -1. And then we're going to square that value. It's going to give us +1, which is the same thing as saying -1 is equal to A, take away 4, right? And then we just, to isolate A, to get it by itself, we're going to add 4 to both sides. adding 4. And when we're done, we get a is equal to -1 plus 4, which is 3, which is what we thought it was earlier, and this is just a way to confirm. So finally, our full formula is writing out a, which is 3, x minus 1 squared, take away 4. So just so we're clear, we did 2 things. First, we started with the vertex, right? The vertex was step 1, and the next step was to find some point that this graph passes through. Plug it in, and we can solve for our unknown. Okay. So we're going to find with the next question that we don't actually have to have a graph to do that. So the next question is question 2. We're going to do 2g next. So this question has all the information that the graph had, well, that we used. It doesn't have all the information the graph had, but all the information we used, it does. So 2g, again, asks us to find the equation of the quadratic function that satisfies the given conditions. So we're going to find the equation of a parabola that has a vertex at 1, 4 and passes through a point 2, 3. So let's try that here. Question 2, we know we have a vertex at 1, 4, and that, of course, is our h and our k value, right? And we know it passes through the point 2, 3. Okay. So the first thing we do if we're asked to find the equation of a parabola is we write out a formula, y equals x minus h squared plus k. Okay. And then we say, okay, well, I know the vertex. So we're just going to plug in any information we know. We might not always know the vertex. We do in this case. So we're just going to rewrite that as x minus 1 squared, and then plus our k value of 4. And this is kind of similar to the last question, except we don't have a picture. If you want, you can draw this picture. Go for it. Take a second, draw out your vertex, and draw a parabola such that it passes through the point 2, 3. That might even help you get a picture of what's happening here. In fact, if you can visualize this, you could probably figure out our a value without doing any more algebra. But maybe you can't, and that's fine. So we're just going to take those x and y values and punch them in. And so that y value becomes 3, and our a value becomes 2. Okay. And so then we get 3 is a, and we simplify, right? Simplify as much as we can. 2 take away 1 is 1. Squared is 1 plus 4. So we get 3 is equal to a plus 4. And we subtract 4. We subtract 4. And I get a is equal to -1. So we can say our formula for our function then is y is equal to negative x take away 1 squared plus 4. All right, let's just take a second to sketch that. Picture it. I really encourage you to try to imagine what we're doing here, not just get stuck in the algebra. Okay, so there's my vertex at 1, 4, right? And I know it passes through the point 2, 3. So I can already know from my vertex this thing faces downward, which is what it says here. And it looks like it goes over 1 and down 1, which means their vertical stretch or compression factor, there is no stretch or compression. It just goes over 1, down 1. Okay, so I like to take a second to make sure I can visually confirm what I've just done. Okay, so that's question 2G. Okay, cool. Now, let's move on to question 2. And I'm going to grab a highlighter. I'm going to highlight all the key information in question 2 here. Question 2 says we're going to give the equation of parabola. Oh, you know what? Before I even start then, if I'm asked to give the equation of parabola, the first thing I'm going to do is write down my general form of a parabola. Okay. And then I'm going to say, oh, okay, it has an axis of symmetry at x equals 7. All right, that's a piece of information. It has a maximum of 4. And and it passes through the point 5, 0. Okay. So I guess that's an x-intercept, 5, 0. All right, so if you're having trouble picturing how this information all fits together, I might just sketch it out. Say, okay, well, there's an axis of symmetry at x equals 7, right? It has a maximum of 4, meaning 1, 2, 3, 4. That's its highest point. So we know that it's going to have a face downward, right? That's what a maximum means. And obviously the axis of symmetry is going to cut it in half, which means we actually kind of know our vertex here is just told to us in a different way. We have an x value for that vertex of 7 and a y value of that vertex of 4. That's our vertex. So we can use those values of 7 and 4 and punch them in, just like we had before. So we got x minus 7 squared plus 4. Okay. And lastly, we know it passes through this point 5, 0, which means it passes through this point 5, 0. And again, if we want to, we could probably construct an argument about the stretch or compression factor based on the fact that this vertex is 7, 4, and it went over 2 and went down, from 4 went down to 0. And so I already have an idea what the compression or stretch factor is going to be. But let's just do some algebra to confirm here. So the point 5, 0, I'm going to let be my x and y values, right? Because they should be a solution to this equation. All right, so I'm going to plug in 0 for y. And my a value, I'm just going to leave as a variable, and my x value is 5. Take away 2 squared and add 4. Okay, and then I simplify as much as I can before I start doing any algebra. And I'm going to get 5 take away 2, which is 3. I'm going to square that. It's going to give me 9 times. Okay, and those kind of look similar. So I'm actually going to rewrite it just like 9a plus 4, because that's like algebra I'm sort of used to. Okay, so there's two things happening here, a multiplication and an addition. So which thing should I get rid of first? And a lot of you intuitively know to get rid of this guy, but we are seeing some situations where we have lots of different algebra steps. We have to think of a method. So some people like to think of SAMDEB, like a backwards bedmass, to figure out which operation you do to undo, to do the algebra, to get things away from the variable side, which is different than bedmass, which we use when we simplify. Use bedmass to simplify. That's for simplifying. And SAMDEB is for algebra, isolating. So that's one way. So we're going to start with any subtractions and kind of get rid of those first. We don't have any, so we'll move on to additions. So then we'll subtract 4 from both sides. That gives us negative 4 is equal to 9a. And then we'll look and say, okay, I have a multiplication here, so that's the next thing I'll get rid of. So I'll divide by 9 and divide by 9. And my a value is negative 4 ninths. That's interesting. It's not actually what I thought the compression was. In fact, why do I feel like that's wrong? Negative 4 ninths. Go over 2, went down 4. It should be just negative 1. Oh, I see why. I changed that into a 7. 2, rather. And so actually 5 take away 7 is negative 2. Oops, okay. Yeah. So we should have got 0 is equal to a times negative 2 squared plus 4, which gives me 0 is equal to negative 2 squared is 4, so 4a plus 4. Okay. Now that's looking a little better. So I'm going to take away 4 from both sides. And I get negative 4 is equal to 4a. And divide by 4. Divide by 4. And I get a is equal to negative 1. And so overall we get this formula. We have negative, and we have x take away 7 squared plus 4. Okay. And I can see here, yeah, it goes over 1, down 1 probably, right, to get to 6, 3. And went over 2 to get to 5 in the x. Went down 4 to get to 0 in the y. So that actually confirms the idea that there's no stretch or compression factor here either. Okay, let's move on to the next question. Okay, so this question asks us to give the equation of a parabola. Oh, so we'll just stop there. Y equals ax minus h squared plus k. And now I'm going to start reading. I've said the equation of a parabola has a single x-intercept at 3, 0. And it has a y-intercept of 27. Okay, so that's interesting. It's a little different than we've seen before. And really, the point is not to memorize every single type of operation to do every time we have a particular question type. The point is to maybe fill in anything we can based on the information we're given. So what I would do is I would start by sketching this graph out. Say, okay, what does it look like if you have a single x-intercept? So let's just draw that out a bit. 3, 0. So that would be 3, 0. Okay. And a single x-intercept. So I can picture a parabola having 2 x-intercepts, or a parabola having 0 x-intercepts, but having 1 implies it's just going to sort of kiss off that graph. So, oh, okay, it looks like actually being told that x-intercept told me a different value of my function that was important. That was a vertex. So the vertex is at 3, 0. So that allows us to go over to our formula and get started. You know, we have an x value and we're going to take away, so that's going to be an h and a k, right? So we're going to take away 3, our h value, and we're going to add 0. Pardon me. So, okay, so I'm just going to rewrite that without the adding 0, because you don't need to write that you're adding 0. Okay. And lastly, it says we have a y-intercept of 27, which means we know the x and the y coordinate of that y-intercept, because all y-intercepts have an x coordinate of 0. And it's a 27, so it hits up there at 0, 27. Again, you could probably count 3 over to the left and figure out how much you went up, and then figure out what you must be multiplying by to get there. And that's actually a great way to go. But if you're not comfortable with that, we're going to go over the algebraic method as well. And the algebraic method, pardon me, always works. It doesn't just work when it is a nice number. Sometimes they're gross numbers. So we got an x and a y here. I'll punch those guys in. So that becomes 27 is equal to a. And my x value is 0. I'm going to take away 3 and square it. And so then I'll say, okay, 27 is equal to a times negative 3 squared, which is 9. So 27 is equal to 9a. And to isolate a, I do the opposite of multiplying by 9. I divide by 9. And it gives me a is equal to 3. Okay. And now I can see, normally if you go over 3 with a parabola, you would go up 9, right? But instead of going up 9, we went up 27, which is 3 nines. So that is a visual confirmation that what we were doing was correct. And that's our parabola. Okay, cool. Let's move on to question quattro. Give the equation of a parabola. Okay, so the first thing I'm going to do is I'm going to just write out my general formula before I do anything else. Give the equation of a parabola. So what does it have? It has an axis of symmetry of x equals negative 2. It has a range of y is bigger than 5. And it passes through the point negative 4, 10. Okay. So let's try this question out. All right, so again, maybe I'll get a little sketch going. So I know it's got an axis of symmetry at x equals negative 2. Okay. It has a range of y is bigger than or equal to 5, meaning when y is 5, right, that's the smallest value. So I know that. I also know it passes through the point 410. Okay, so 410 is going to be passed through there, I guess. So 410. That's a point that this passes through. All right. Oh, pardon me. 410 is actually below 5. Passes through the point 410. Oh, no, pardon me. 410. I was just being crazy for a second. 10 is above 5. Okay, so it's going to pass through the point 410. Okay. Great. So what do we know? Well, look again. That vertex is sort of embedded in this question. We know the axis of symmetry is at -2, so that means it's passes through the vertex, right? And the range tells us something about the vertex as well. So our vertex is actually given. So our vertex is -2, 5. Okay, so we're going to punch those guys into our equation. So first, we're going to say, and that's our h and our k, right? So we know that we're going to replace h with -2 and square it and then add 5. Now when you take away a negative, that's the same thing as adding, right? So actually typically we see it as x plus 2 squared plus 5. And that's how we would normally see it, right? You think of flipping it, so if it's negative, you put the positive in there. But that's why, that's the math behind why, right? Okay. And we know one other thing. We know it passes through the point 410, which is an x and a y. So I'm going to replace my y with 10, and leaving me with one variable because my x is going to become 4 plus 2 squared plus 5. And then we get 10 is equal to a, and 4 plus 2 is 6 squared plus 5. So I get 10 is equal to 36a plus 5. Again, I have to use SAMDEB so I use BEDMAS to simplify to what's in the brackets, and then I did the exponents, right? That's BEDMAS. That's for simplifying. And now I'm going to do the opposite, because I'm going to do algebra, because I have to choose whether I get rid of the 36, which is being multiplied, or the 5, which is being added. And I do the opposite, which is SAMDEB. This is for isolating. So you don't have to use SAMDEB, backwards BEDMAS, if you don't want to. There are other ways to think of it. We talked about like the dinner plate rule to govern how we know what thing we get rid of first. But in this case, we're going to get rid of this addition first. We're going to take away 5. So 10 to take away 5 is 5. And we get 36a here. And then we go across. We see there's a multiplication of 36 times a. So we're going to divide by 36 on both sides. And it gives us a is equal to 5/36. All right, so this was a case where it wasn't necessarily easy to see how much you go over and up just by the diagram. And this is why the algebraic method is good to know, because it'll help us find our answer even in cases where we don't get friendly numbers. Speaking of not friendly numbers, let's look at the last question here. So the last question has a lot of words in it, right? And this is what these sort of formulas are sometimes used for, is modeling real-life situations. So this question talks about the deck of the Lionsgate Bridge suspended from 2 main cables attached to the top of 2 supporting towers. So in case you can't picture the Lionsgate Bridge, or maybe you're having trouble visualizing what that means, we can look in this diagram here, which isn't great, but we can see there is a deck. It doesn't show up so well on the video, but there's a deck here, right? That's the deck. And there are 2 main towers. And these cables from the towers support the weight of the deck, and that's the definition of a suspension bridge. You have these 2 towers, and they hold up the rest of the deck. They suspend them in midair. And we say the main cables take the shape of a parabola as they support the weight of the deck. So we see here we have this parabola shape, and it looks like it's sort of compressed a little bit. Okay. And so the towers are 111 meters tall, right? That's from here to here, 111 meters tall relative to the water's surface, and they're 472 meters apart. And the lowest part is here, which is 67 meters. So what I'm going to do is I'm going to start by just transferring that information onto a graph here. Okay, so I can imagine, I'm going to imagine putting an axis here. Okay? So what I can do is I can picture that there is one point here at the top of that. So that's the point 0, 0, right? And that's going to be the bottom of my first tower. And the top is going to be 0, I'm going to call it 111, right? Because that's the top of the tower, of the first tower. Okay, and if it says that this one is 472 meters apart, which means along my x-axis, I'm going to go 472 meters. And if I go up from there, I get a point at 472 in x and 111 in y. And that's great. And there's one other piece of information, which is the lowest point, which is also the vertex, right? That's going to be around here. So it says it's 67 meters above the Earth's water surface. And we know that parabolas are symmetrical, right? So we know that halfway between 472 and 0, or 472 divided by 2, which is 236. So this is point 236, 0. Halfway between them, we're going to get a point up here, which is 67 meters tall. And that's a point 236 and 67. So this is 0, 67. That's that point here. And this is point 236, 67. 236 in the x, 67 in the y. And if we draw a little sketch of those supporting cables, we have a picture of our parabola now. Of course, it should go through that point. And if you want to embellish, you could show those towers, right? That's the second tower, tower 2. And you can draw this one in as well, right? That's tower 1. And you could almost imagine that we had this sort of deck here as well. That's kind of the deck. And there's our graph. But we've superimposed onto that some information, about x's and y's. So now we know this is a vertex, right? This is a vertex. It's where our point passes at the lowest point. Now, had we chosen a different place to put our axis, we could have chosen it here. That's fine. We could have figured out where everything else is relative to that. I just chose, it made sense for me to put an axis here. Okay. So first question asks us to find the quadratic equation. So we're going to do y equals ax minus h squared plus k, right? That follows it. So first thing I'm going to do is I'm going to put in my value for my vertex. Y is equal to a x minus, and my x coordinate of my vertex is 236. I'm going to square it. I'm going to add 67. And the next thing I'm going to do is I'm going to choose another point that the graph passes through. I could choose this one or this one. I'm going to choose this one because it's got a 0 in it. And that tends to be easier to plug in my experience. So I'll put in I'll use the point 0, 111, which is to say that's an x and a y value. So I'm going to put my y value of 111 as equal to a, my x value is 0, take away 236 squared plus 67. Okay, so I'll do some simplification here using BEDMAS. First I'll do the brackets. I'll do a 0 take away 236, which is negative 236. And then I should do my exponent step, which is squaring 236. So negative 236 is some number, and I'm going to square it. And I get 55,696. Okay. So I'm going to replace that with A times 55,696 plus 67. And then I'm just going to do some algebra. I'm going to remove my 67 from each side. And then 111 take away 67 is 44. 44 is equal to, I'm going to change the order of this, 55,696A, and I'll divide by 55,696 on both sides. And I'll give you my A value. And so it will be a gross fraction. So I'm going to try to simplify that fraction. So it's going to be 44 over 55,696. But I should probably try to simplify. They're both even, so I can divide them both by 2 at least. So I can say it's 22 over, what is 55,696 divided by 2 anyway? Oh, it's also even, so it's 27,848. And those are both still even, so I can divide them both by 2 again. So I can get 11 on the top. And that number divided by 2, is 13,924. And that's equal to our A value. Great. So our whole formula for this is y is equal to 11 over 13,924 times x minus 236 squared plus 67. And that's a function that tells us any point along this curve. All right, so let's try and use it now. So the next question, the last question, asks us to use it. It says, determine the height above the surface of the water that a point on the cables that is 90 meters horizontally from one of the towers. And we'll round that to the nearest tenth of a meter. So 90 meters away. So that means I can start with this tower, say, and move 90 meters in the x direction. 90. Right? And we're looking for the value, the y value, that matches that. So 90, and what's our y value, right? That's what we're looking for here. Okay, so for 5b, we're looking for the point. So x is 90, y is what? Or in other words, our input is 90. What's our output? So what we can do is we can use this formula to solve for that. Our formula is y is equal to 11 over 13,924 times x minus 236 squared plus 67. And I can put in a value of 90 in for my x, and I can solve for my output, my y value here. And so I'm going to do that. I'm going to say, okay, so my y is equal to 11 over 13,924. And I'm going to put 90 in here. 90 take away 236 squared plus 67. And say, okay, let's do some algebra here. Let's do some bedmaths. So we'll do brackets first. 90 take away 236. So I get negative 146. Negative 146. I'm going to square that value and add 67. So first I'll square this guy. That's the next thing. I did my brackets, and I'll do my exponents. So I'll square that value. Oops. And oops, I squared it twice, so I'm just going to undo that. All right, so I'll try it again. 146 squared. 146 squared. It's 21,360. So y is equal to 11 over 13,924 times 21,316, and then we're going to add 67 to that. And then when I multiply this by this fraction, so I'll multiply this by 11 over 13,924. I'm not sure if this is going to give me a syntax error. That's a really big denominator for the fraction button to handle. Oh, it worked. Okay, and it gave us a value. It gave us y is equal to 16.8. Remember, we're rounding to the nearest tenth plus 67. So this tells us that the height of the cable 90 meters in is this number plus 67 meters, which is 83.8 meters high. And that's how we do that question. And this is what we learn about modeling ideas with formulas for, so we can solve problems like this. All right, guys. Let me know if you have any questions with this. Email me or come see me during Flex. And good luck studying, guys.